Okay, today I want to start talking about safety in the HVAC industry. So to begin, what we need to discuss is why is safety so important? You know, in our industry, we deal with a lot of hazards. We deal with everything from refrigerants to electrical. We deal with high-rise. We deal with ladders. We deal with pretty much every aspect of the industry and are really put into a lot of different situations where we can easily be getting hurt. But to really begin with everything, it's like the safety, and where did it begin? Well, it began with the government. The Occupational Safety and Health Act is a national law that covers workplace safety. Okay, the law covers the safety requirements of equipment as well as the personal safety of the technician. Okay, you can become familiar with a relative safety standard by visiting the OSHA website. The OSHA website is actually pretty decent to go on. I would definitely recommend at least breezing through it. They do have a lot of really good, helpful information on there to kind of help you and protect you in certain situations. Okay, the information on the site can be found in different categories, such as your construction and general safety. So we've got a lot of things that go into it. Okay, companies are required to report to OSHA every fatality or permanently disabling injury or any accident involving 3 or more hospitalized injuries. Okay, that is an actual law, and OSHA actually does require that. In HVAC, installations and repairs can be done indoors, outdoors, and in either residential or commercial settings. Okay, like I said, we're going to be in a lot of different areas and a lot of different situations where we could be in a really hot attic or we could be on a cold roof in the middle of the winter. Okay, using and wearing the correct personal protective equipment, or otherwise PPE, will ensure the comfort and safety of the technician. Working on rooftops, on suspended ductwork, and ceiling plenums all present potential fall hazards. Okay, always evaluate the workplace that you're at. Make sure you are free of all safety issues or anything that you might have a concern with. You might want to bring it up with your supervisor, or maybe if you're on a construction site, maybe get the general contractor or the person that is in charge and show them the hazard that you might have a concern with. Okay, always use safe practices for climbing and using ladders and also scaffolding. Okay, always watch what you're doing. A technician should be alert to emergency procedures and the location of main electrical disconnects and gas shutoffs, just in case of an emergency. God forbid something was to happen if you were on the job site. Okay, in addition to this, we deal with chemicals and refrigerants which can be dangerous to the skin, eyes, and respiratory system. Okay, one big thing that we definitely deal with in HVAC is refrigerants. Okay, refrigerants is a chemical. Okay, if a massive leak is big enough and we are in the area of that refrigerant leak, yes, we can suffocate. Yes, it can kill us. Refrigerant, if it gets on our bare skin, it can cause frostbite. It can do damage. Gets into our eyes, we can go blind. Okay, so always be careful when you're dealing with all of these things, because obviously at the end of the day, you want to come home with all of your fingers and toes and both eyeballs. Okay, it is the technician's job and responsibility to be aware of safety data sheets on a particular job site. Okay, during the winter and summer months, technicians may work an excessive amount of hours and become tired, which can result in obviously carelessness. HVAC is not a 9-to-5 job, especially if you get into that service end of it. Okay, in the service side of stuff where you're humping and you're doing a lot of repair and service call work, you can easily pull 60, 70, 80-hour weeks. Okay, construction sites usually are around 40, maybe 50 hours a week. It depends. It depends on the job. It depends on the company. It depends on what's going on. But either way, you work, and then there are going to be a lot of times where you will be tired. So obviously when you're tired, you become careless, you become clumsy, and you might start doing things that may not exactly be the best thing to do. Okay, it's important to remain alert and aware of your surroundings while on a job site. Always look around. Make sure that everything is safe, okay? Like I said, you do not want to get hurt. Okay, according to OSHA, in practical terms, a hazard often is associated with a condition or activity that, if left uncontrolled, can result in injury or death. That's what OSHA actually defines as a incident or a hazard. Okay, a hazard is a potential for harm. Okay, by identifying, eliminating, or minimizing hazards will ensure the safety of the technician and others around you. Okay, OSHA's website provides detailed plans for conducting a formalized hazard assessment. And like I said, go ahead, visit the OSHA website and check it out, see what's on there. Okay, a simple hazard assessment should be performed by technicians on arrival to the work site. So basically what we're saying there is make sure you look around. Okay, be aware of your exit signs and your emergency exits. Locate the first aid equipment that's there. Okay, presence of hazard material or chemicals. Okay, where are they? Are they properly secured by law? Anything that's a hazard has to be either properly stored or chained up. Okay, it can't be just lying around on a job site. Okay, it can't be rolling around in the back of a service truck either. It's supposed to be properly secured. If it's not, that's a hazard. Okay, it might want to be addressed. Okay, any ventilation concerns, especially if you're going to be doing a lot of welding or some sort of brazing job for pipes or stuff like that. We don't want to be inhaling any sort of toxic fumes. Okay, that can cause any sort of internal damage. Okay, what's unsafe in this picture? I mean, geez, look at this. There's a lot there. Okay, I mean, look, we're using wood for a plank. Okay, I get across a little area here. Okay, that's a hazard right there. There's no guardrails right here. Okay, this is all fall. This is all falls that can actually take place. Okay, it looks like these two guys back here, it looks like maybe they're trying to throw something to each other or somehow try to hand something to each other. Yeah, that's not exactly a good thing. I mean, look, we got tarps. Tarps aren't properly secured. They're lying around. These are all bad situations, and obviously if OSHA did show up on this job site, there would be a lot of fines going on. This job site would probably get shut down due to the fact is that it's just simply an unsafe situation for everybody. Okay. Second, electrical hazards is second to a nuclear reaction. Okay, an electrical arc is the hottest thing on Earth. Okay, we can suffer from what we call arc flash if we are not careful with electricity. Okay, an electrical arc is 7 times the temperature of the sun, or the sun's surface. So if we were to ever experience an arc flash, we can seriously get burned. People actually have died from arc flash. So when we are dealing with electrical, we need to really be careful and be really mindful of what we are doing. Okay, electricity can cause shock, it can cause burns, it can explode. Okay, and ultimately it can cause electrocution. Okay, electrical hazards are the most difficult to identify sometimes in the field, simply because they are oftentimes no obvious visible signs that's going to alert you of a potential issue. Okay, it really is a dangerous thing to be around, so we have to always be mindful of that. And a way that we use to protect us is using Lockout Tagout, okay, a Lockout Tagout system, and that is critical for safety, especially when you are on major construction sites and there's a lot of stuff going on. Okay, systems that require lockouts include your electrical systems, your hydraulic, your pneumatic systems, any mechanical stuff that's going on, and anything that is thermal related. We'll all have a lockout tagout situation. Okay, never expect others to shut off the power source when you are on a job site. You should be the one to verify that the electrical power source to whatever it is that you are working on is shut off. Okay, use an electrical meter to verify that this stuff is off. Say, as a technician, you should personally shut the power off and ensure that the circuit you are working on is in fact de-energized. Always assume the power is on until you have verified that it is shut off. Okay, use an electrical meter to verify that that piece of equipment is indeed shut off. Okay, the lockout tagout system is actually two separate practices that is combined into one. You have your lockout section, which is the practice of locking the mechanism or electrical switch in the open or off position so that service and maintenance can be performed safely. And you have your tagout portion of it, which is the practice of placing a tag on the mechanism or electrical switch to inform others that service is being done and in progress, and that the system being worked on should not be touched or energized. Okay, hence lockout tagout. Okay, so we have those all the time. We look at this picture here. This is a lockout tagout of a breaker. Okay, here's our lock. Here's our little tagout right here. This little mechanism right here with our tag. Lockout, tagout. Okay, the tag will have the name, the department, the time, and date of whoever was working on this piece of equipment last. And the only way that this lock will ever come off is the person who holds the key. And if you notice in the picture, the key is missing. Okay? Anytime we use a lockout tagout, you take the key. You have the lock, you take the key. The only way that thing will ever get energized again is if you remove that key or remove that lock with the key that you have in your possession. Okay, OSHA standards state that the technician must use lockout devices for equipment that can be locked out. Tagout devices may be used with a lockout device only if the tagout program provides employee protection equivalent to that provided through a lockout program. Okay, so what they're saying is you may not necessarily have both a lockout tagout thing, but as long as you have something that is of equivalent to providing a lockout program, it is okay to do. Okay, electrical panels have a location for a padlock to use for lockout. So in order to prevent the power from being energized, the panel should remain locked until it is ready to be energized again and everybody has cleared that workspace and is ready for it to be turned on. Okay, we can buy lockout kits such as this. Okay, it comes with all different accessories here on all different things to do and use for different lockout situations. Okay, on occasions it may be necessary to work on live circuits. There will be times in HVAC where you will have to troubleshoot systems with the power on, and again, you always have to use caution and be very careful when you're doing so. Okay, you're going to confirm the voltage of the circuit being checked and verify that your test meter is set in the proper setting. Okay, make sure that the meter probes touch the live equipment only. Okay, keep all skin and parts of your body clear of electrical terminals and connections. We never want to stand in wet or damp areas when checking live connections. And when taking electrical measurements, wear shoes with insulated soles and heels. Okay, so we want to make sure that we're not wearing sneakers or flip-flops on a construction site. That's not exactly a good thing to do. Okay, electrical shock occurs when the body becomes a part of the circuit. Okay, this happens when electricity flows through the body, which can affect the heart, causing death if enough flows through it. Okay, you need to remember that the human body is made up mostly of water. Electricity and water do not mix very well, so if electricity goes through our body, yeah, we can potentially get electrocuted. Okay, every technician should learn first aid and CPR. I do believe that there are some companies out there that do require it. So obviously when you get out into the field, you might want to look into doing that, making sure that you at least learn first aid. Okay, and when using electrical tools, make sure they are properly grounded and connected to properly grounded circuits. Okay, older power tools were constructed with metal frames, and obviously back in those days the metal frames would create an electrical shock and potentially hurt or kill somebody. Okay, and if using these types of tools, confirm there is a ground wire on the power cord, and in the event of a short in the power tool, the ground wire will carry the current rather than through the body. Okay, and this will cause a fuse or a circuit breaker to open in the event that this thing actually does happen to short out on us. Okay, if using extension cords, they should be connected to a ground fault circuit interrupter or a GFCI. Okay, the GFCI is a fast-acting circuit breaker that will shut off power within 1/40th of a second in the event of a ground fault. Okay, an electrical current leak to ground will cause that GFCI to open and take out the circuit. Okay, modern tools tend to be made of plastic casings and often battery powered. Okay, the motor and tool is insulated within the tool, ensuring worker safety. So practicing extreme care when using screwdrivers and other tools in an electrical panel when the power is on. We do not want to create a short circuit to ground when we are doing any of this type of work. And this occurs when power flows through the metal tool, which can cause an electrical arc resulting in electrical burns, such as this poor guy right here. Okay, that's not exactly the greatest of pictures. It's pretty ugly in my opinion, but that is what can happen if we are not careful. Okay, we do not want to wear jewelry when working on live electrical circuits, as they can conduct electricity. Okay, we also have to deal with fire hazards. Okay, in HVAC industry, we deal with solvents and fuels and other flammable and combustible material. So when using these, a technician must be aware and use caution when working near items capable of producing ignition, such as burners and torches. Okay, so to name two, is we deal with oil burners, we deal with natural gas-fired furnaces. Okay, we deal with propane. So all of these are all flammable things. We need to make sure that we know what we're dealing with in the event of a fire. Okay, look for symbols indicating the flammability, such as you see in this picture right here. Flammable sign. Is it flammable? Yes or no? Okay, fire is a chemical reaction. Okay, a technician should become familiar with the use of a fire extinguisher in the event a fire does occur. Okay, the average fire extinguisher contains about 10 seconds of extinguishing power. Use them wisely. Okay, it's important. We do not want to just use a fire extinguisher on a small little fire, but we do want to make sure that we have a fire extinguisher next to us just in case we need it. Okay, there are different types of fires based on the type of material being used and consumed. Okay, and fire extinguishers are marked with symbols identifying the types of fires they will handle and put out. Okay, so like you see here in this slide here, okay, Class A fires. Okay, those are your ordinary combustible materials. Okay, your wood, your papers, your rubbers. Your Class Bs is your flammable liquids and gas, such as gasoline, oil, and paints. Cs are electrical equipment. Okay, Ds are your combustible materials and alloys. Okay, and usually a D is going to have the D with a star on it. Okay, and your Class K is all of your cooking appliances that involve combustible cooking media, such as vegetable and animal oils, fats, stuff like that. Okay, always look at your fire extinguishers and see what type of pictures. Okay, usually they will have pictures that come with them. Okay, a little line through it means, hey, it doesn't work on those. So your Class A's is only for your papers and your rubbers and your wood type fires. Your A and your B's can be worked on your flammable liquids and combustibles, ordinary combustibles. Your A, B, C's can use everything. Okay, so we have all different types of fire extinguishers out there. It's always good to know and learn. Okay, to operate the extinguisher, we use the pass analogy: pull, aim, squeeze, and sweep. Okay, so we always want to make sure that we learn how to use a proper fire extinguisher. Okay, never use a water extinguisher on an electrical fire. Only use Class C's. Okay, temperature hazards. In HVAC, you will be exposed to extreme range of temperatures during installation and service. Like I said before, we can be in a blazing hot attic working on someone's air conditioning in the middle of the summertime. We could be working on a cold roof in the middle of a snowstorm, in the middle of winter, fixing someone's heat. Okay, so we always have to be able to wear the appropriate clothing to protect ourselves. Okay, from everything from UV rays to the sun to extreme cold. Okay, always drink plenty of water and stay hydrated, especially in the summer. Wear plenty of layers of clothing, especially in the winter. Signs of heat-related illnesses can be anything from elevated body temperatures to confusion. Okay, it all depends on what we're dealing with. Okay, working in the winter months can cause its own issues on the body. Wear appropriate clothing and waterproof boots. Okay, and wear layers of clothing during the winter time. All my years in the field, I always used to wear a lot more layers than I think I should have. And as the day went on, if I felt that I needed to take off a layer of clothes, I would. Okay, it's also a good idea to keep an extra set of dry clothes in your truck or van during the winter months and summer months, so that you can actually change and, put on some dry clothes instead of having to drive home in cold, damp, or wet clothes. It's always a good idea to do. Okay, be alert of hypothermia and frostbite. Okay, hypothermia symptoms include shivering, increased pulse, increased breathing rates, loss of coordination, confusion, and loss of consciousness eventually. Okay, if hypothermia is suspected, we want to obviously call 911 and try to move that person to a warmer location. Okay, frostbite occurs when temperature is below freezing. Okay, symptoms of frostbite include redness of the skin that develop gray and white patches, or numbness in the affected area. Okay, you see something going on like this where their fingers or their hand is starting to turn white, that is frostbite. Okay, we want to definitely try to take care of that. Call 911 and get the people to proper help. Okay, another picture of it right there. Okay, attics, roofs, and mechanical rooms can be extremely hot or cold. Okay, working in low temperature freezers, especially if you want to get into the refrigeration end of things. Okay, refrigerants can cause frostbite or burns. Okay, the severity of the burn or frostbite depends on the temperature and pressure of the refrigerant, the amount of refrigerant, and the length of time of the exposure. Okay, one thing to always remember in the heating and ventilation air conditioning field is that temperature and pressure will always coincide with each other. Okay, the higher the pressure inside the cylinder, the higher the temperature. The lower the pressure inside the cylinder, the lower the temperature. Always remember that. That will save you and will honestly make you understand a lot of other concepts in HVAC. Okay, breathing hazards. Work sites can have a variety of harmful substances such as dust, asbestos, adhesives, and solvents. And when using adhesives or resins, be certain to work in well-ventilated areas. Okay, in the past, asbestos was used as insulation in homes, around piping, and in furnace rooms. Okay, today, we are made aware of the dangers of asbestos. Okay, and if inhaled, they can cause cancer. Okay, so nowadays, if we run into an old building that still has asbestos in it, we are supposed to at least notify the homeowner that that asbestos should be removed, or business owner that that asbestos should be removed from the building. And if not, at least it needs to be patched and covered up so that it doesn't create any sort of cancerous hazards for anybody that happens to be in there. Okay, so when cutting or removing the asbestos, ventilation system with a HEPA filter has to be used. Okay, and here we are. This is what asbestos would actually look like. It's kind of like a hard-looking material on it. As you can see right here, this is a piece of asbestos that has broken away. So this is actually a hazard. We don't want to see this stuff like that. Okay, we want to document stuff like this if we are on job sites. Okay, personal protective equipment. Like I said, on construction sites, various hazards will be encountered. Okay, potential hazards can either be health or physical. Okay, a lot of your health hazards can be overexposure to harmful chemicals, dust, radiation, you name it. Physical hazards, high heat, electrical connections, sharp edges, stuff that can fall, stuff like that. Okay, so personal protective equipment is worn by the technician to minimize exposure to health and physical hazards. Okay, PPE includes gloves, hard hats, goggles, and respirators. Okay, because obviously when we're on a job site, we do want to protect our noggin. Okay, our noggin doesn't want to be, we don't want to hurt it, so we got to wear a hard hat. Okay, because if we do hurt our head, that's going to cause either permanent impairment or maybe a disability in life. So obviously we don't want to hurt it. Okay, so hard hats are protected. Are designed to help the technician from impact, penetration, electrical shock, and burn hazards to the head. Okay, hard hats must always be worn on a construction site and must be worn with the bill facing forward. Okay, determining the need for hearing protection requires consideration of the following for hearing. Okay, the loudness of the noise in decibels, how long will be exposed to the noise. Okay, and if the employee moves between different areas or the noise is produced from a single source or multiple sources. Okay, so OSHA requires hearing protection for noise levels of 90 decibels or greater for an 8-hour day. Okay, so if you are in a location where you have to raise your voice to be heard, hearing protection is most likely needed. Okay, so this is what a chart looks like for different sound decibels that we normally run into. Okay, so I mean technically when we're in a boiler room, we're dealing with about 90 decibels of sound. Construction site, or somewhere around 100 decibels, with with all your drills and jackhammers and trucks and tractors and all that stuff that's going on. We're dealing with roughly around 100 decibels. Now think about it, going to the nightclubs and partying on with the music, we were dealing with about 110, maybe 120 decibels of sound. So no wonder some of us are deaf, but that's what it is. Okay, but OSHA permissible exposure is 90 decibels for an 8-hour period. If we're dealing with about 100 decibels, they only say about 2 hours is the safe level for anything of that nature. Okay, there are 3 different types of hearing protection. You have earplugs, single-use earplugs, which are usually made of foam or silicone. Okay, and they are self-forming when they are inserted into the ear. You also have your preformed earplugs, which fitted by professionals, and these can be either disposable or reusable. Or you have your ear muffs, and those must be sealed perfectly and completely around each ear. So you got different types ones there. Okay, eye protection. A majority of the injuries on a job will result from an object falling or flying, such as a spark flying out into the eye, something like that. Always wear safety glasses or goggles with side shields when you're on a job site. Okay, full goggles should be worn when performing work in a dusty area or when using power actuated tools such as a nail gun. Okay, do not try to be Hercules in any way. If the object you are trying to lift is too heavy, obviously use the proper tools when you are lifting anything. Okay, use hand trucks or portable dollies, pry bars, and that's what they're made for, to help move heavy objects. Okay, last thing you want to do is hurt your back. Okay, always ask for assistance if needed. Okay, a lot of this stuff is very much common sense, but hey, you know, you'll be surprised on how many people out there actually hurt themselves because they want to try to do it themselves. Don't be that person. Okay, always consider wearing a back brace for proper back support if needed. Okay, lift with your legs, not with your back. Okay, ladders, they should be non-conductive. They should be fiberglass. They should not be metal. When you're on a construction site or doing any sort of ladder work near electrical wires, you should always inspect your ladders for defects, damage, or deterioration. Be certain there is no grease or oil on the rungs of the ladder, because that would really stink if we actually are on the rung and we happen to slip on some oil that happened to be on the rung. Yeah, that's not a good day. Okay, portable ladders must have non-slip feet on them, and ladders should be set on firm ground when we are using them. Okay, always follow the guidelines for ladder safety. Okay, place the ladder on a stable level ground. Okay, position the bottom of the extension ladder no further away from the wall than 1/4 of the supported height. Okay, and if the ladder is being used to access an upper area, such as a roof, the ladder must extend a minimum of 3 feet above the step-off surface. Okay, when you're setting up an extension ladder onto a roof for 3 feet, that means that extension ladder should extend 3 rungs above the roof line. That is considered 3 feet. Okay, so if anybody was never understanding that or didn't understand that, hopefully now you do. Okay, ties. Tie, block, or secure the upper part of the ladder where it meets the roof to prevent it from slipping. Okay, and follow the maximum carry capacity of that ladder. Okay, always use a 3-point contact rule. Should be used, as it minimizes the chance of slipping or falling. Okay, climb the ladder facing the ladder with 2 hands. Okay, use a tow line or a tool bag to carry materials to the roof, and do not overreach or lean while on the ladders. Okay, scaffolding is another area that we are going to run into a lot of times on construction sites. Okay, scaffoldings must have toe boards, mid rails, and top rails. Okay, platforms must be at least 18 inches high. That is an actual OSHA regulation, and if it's not that way, OSHA can come into the job site and actually fine you. Okay, scaffolds must have ladders for proper access. A fall protection device or safety cage is necessary for scaffolding over 16 feet high. Okay, scaffolding wheels must be in the locked position when the scaffold is in use. Okay, and is required if a technician is working at heights higher than 6-foot drop. Fall protection must be used when working around moving machinery. Okay, fixed fall protection should include a wall or guide rail of at least 42 inches high. Okay, and if anything's up there, that's what you're technically going to be wearing, a full body harness where it goes across your shoulders, your chest, and it attaches across your legs. So in the event of falling from heights of 16 feet or more, this body harness would sufficiently protect you from any damage. Notice safety glasses and a hard hat.